Hey, how you doing? Hope you're all doing well. Getting ready for this quiz. Remember, we are all fallible human beings. Just a quick note, I'll go through all these problems. I'll do the best I can. This is the first time I'm recording on my iPad in a while, and the screen has been broken, so I may have some glitches here. Hopefully not, but in any case, here we go. So for the first one, we've done plenty of problems like this. We know to solve for x, we are going to undo multiplication. We divide, so we divide by -9, those cancel. Negative turns positive, 72 over 9 equals 8. Moving on to here, undoing subtraction, we want to add 16, cancel, x equals, we have -21 plus 16, there's some glitches. Negative will give us -5. And note, you can go back to your floats and anchors. -21 is 21 anchors and 16 floats, so that it's 21 anchors and 16 floats, so put us at -5. For the next one, we want to multiply, undo division, we want to multiply by the denominator, -9. So you multiply by -9, both sides, these cancel. And we get x equals 5 times -9 will be -45. Coming down to 4, adding 14 to x, so we subtract 14 from both sides, these cancel, and -6 and -14, that would be or 6 anchors and 14 anchors would put us at -20. You also do money, owe someone 6, owe them 14, you owe them 20. When we get to fractions, getting a little more difficult, remember we want to multiply by the reciprocal instead of just dividing by it, because if we divided by it, we'd end up multiplying by the reciprocal anyways. These cancel over here, so we get x equals. On this side, you can put this over 1, and then you can reduce 20 over 5. I'll go ahead and do this in a different color. 20 over 5 reduces to 4 over 1, and then we multiply across. -4 times -8 would be -32, and the denominator of 1 times 1, which is this 1. So -32 over 1 is -32. Coming over to here, another of the same, add 15 to both sides, undo subtraction. These cancel, 15 minus 9, or -9 plus 15, that'll give us a +6. Again, you just use floats and anchors for that. Coming down to here, there's actually a multi-step equation with that negative out in front of x. We have a -12, which is the same as -12, and then we have a -x. So first we want to get rid of what's furthest away. The way we get rid of that -12 is adding 12 to both sides. We have 15 plus 12 is 27 equals. Now over here, keep in mind we did nothing with the -x, so we just bring it down. I'm switching sides though, so the 15 plus 27 comes 27 on the right. I'm just going to move the -x over here. And then you ask yourself, there's two ways you can think of this. One way you could say the opposite of a number is 27. So therefore that number is -27, because the opposite of -27 is +27. The other way you can think about it, this is a -1 out front, and you're dividing by -1, and that will give you -27. Coming to number 8, a fairly straightforward multi-step equation. We want to get rid of the 10 first because that's furthest away from x. So those cancel. I'll go ahead and keep the -3m on the right hand side. 25 minus 10 gives you 15. Divide by -3. And now I'll move m to the left hand side. M equals, these cancel. Positive divided by a negative is a negative. 15 divided by 3 is -5. Over here we have two x terms that are the same. So if I have -1x and -7x, that's combining like terms. That gives us -8x altogether. It's combining the constants, or the coefficients, just like you combine constants. And now we want to solve for x. Undo multiplication, we divide, which would be 32 divided by -8, which will be -4. Coming down to 10, getting rid of that -8. Sorry, my cat's meowing in the background if you can hear that. Add 8 to both sides. These cancel. And now I have k over 3 equals negative 15 plus 8. That would be 15 anchors, 8 floats, puts us at negative 7. And now undo division. We want to multiply by the denominator, which is 3, so those cancel. So we have k equals negative 7 times 3 is negative 21. Two ways we go about it. I will show you both. First way is getting rid of whatever is furthest away from x first. So if we have negative 1 is being multiplied by x first, then we're adding 5 to it, and then lastly we're multiplying by 4. So undoing multiplication of the last is 4. Now see, when we get here, we now have 18 over 4, which isn't a whole number. And then if we're thinking ahead here, we'd also have to subtract 5 to this other side. So I'm not going to continue this because I don't like the fact that I'll have a fraction being subtracted. On the next step, I'll have a fraction minus a whole number. I mean, that's doable, but it's not working out in an efficient manner. So I'm going to stop, and I'm going to go back and use my other method that I can, which is distributing. And then hopefully, and it seems that we'll just stay all in whole numbers. So the work then in terms of solving this will be easier to work with. So when I distribute that 4, I got to multiply it by both terms. 4 times 5 gives us the 20, and then 4 times negative x gives us negative 4x. Now I want to get rid of whatever's furthest away from the x on the right-hand side, which is the negative 20. So I'm going to cancel that out. 18 minus 20, that will be negative 2 equals negative 4x. Now when we get to here, be careful. You want to divide by whatever is on the same side with x, and that's the negative 4. You know, you think usually we do 4 divided by 2, get a whole number. That's not what's important. What's important is what number is with x. The negative 4 is with x, so that is what we're going to divide by. And then I'm going to move the x to the left-hand side. Now if you look here, we have negative over negative turns positive, and then 2 over 4 gives us a half. So we end up getting a fraction still, but it's much easier to work with that fraction after redistributed rather than divided. Okay, coming to this one, that's 5 over 9, even though the x is in the numerator. That's the same as 5/9, very similar to, where do we have it? There, right there, 5/8 x. You could also have written that as 5x all over 8. So when you see this, just think of that as the coefficients of fractions. So we just want to multiply by its reciprocal, 9 over 5. That will cancel over here, which will give us x equals. On this side, again, we're multiplying by that 9 over 5 on both sides. Just a quick reminder, multiply by 9 over 5 here, so multiply by 9 over 5 over here. So now let's go ahead and simplify this. When we look at this fraction, we want to look at cross-canceling. So 3 over 5. We could also look straight down. I don't say that very often, but that's possible. 3/4. Typically, though, fractions initially in the equation are not written in non-reduced form, so they are. But in any case, let's look at cross-canceling. 3 over 5, that does not reduce. 9 over 4, that does not reduce. So therefore, we simply multiply across. 3 times 9 gives us 27, and then 4 times 5 gives us 20. And since there was no cross-canceling there, this fraction of 27 over 20 is not reducible, and you are done right there. Last one, perimeter of a rectangle is 46. Write an equation and solve. So there are two pieces of information in terms of perimeter that we have. One piece of information is that we know that the perimeter is 46. The other piece of information, we have the perimeter in terms of these algebraic expressions. So if we have one algebraic expression for the perimeter of 46 and another algebraic expression for the perimeter in terms of x, we can set those two equal to each other. So what does that look like? So if I have, in a rectangle, we know that opposite sides are equal. And when you get to geometry, we say they are congruent, but we can just simply say right here they're equal. So if this segment is x plus 5, the segment up here is also x plus 5. Similarly, if this is 3x minus 2, we know this is 3x minus 2 over here. Right now I'm just trying to get some information down before I try to process this problem. And now I say, okay, well, I know that the perimeter is 46. What is the perimeter in terms of x, in terms of these algebraic expressions? Well, the perimeter, we add all these up. So if I added all of those, I could write it all out, or you could just say, oh, I'm adding these and combining like terms. So I can combine my x's. I'll go ahead and highlight these, make it a little more obvious. Here's my x term, x term, and x term. And then I'll highlight the constants, -2, 5, -2, and 5. So when I combine the x's, I have 3 of them here, +1, +3, +1, and that is the same as 3 plus 1, which is 4, +3 is 7, plus 1 more is 8 x's, so I'm going to write 8x. Now I'm going to combine the constants, -2 plus 5, and again, you can combine these in any order. This is the order I'm deciding. -2 plus 5 is 3, 3 minus 2 is 1, 1 plus 5 is 6. So the perimeter in terms of x, or in terms of this algebraic expression, is 8x plus 6. But we also know the perimeter is 46, so we set those two equal. And now I'm just going to simply solve that as it asks for the value of x. And so at this point, we're just solving the equation. Cancel those. On the left-hand side, we have 8x equals 40. Now we're going to divide by 8. And x is equal to 5. And that's all we wanted. We didn't want to find anything else there. Not all of that, it's okay. So if we look up here, just to reiterate, write an equation, which we did, and solve for the value of x. So that's our final answer, x equals 5. Best of luck with the quiz, and remember, you are a fallible human being, and I'll catch up with you on Friday. Bye.